project, which was great. They were a good partner for stepping up and exploring new business solutions, and it was important to them as well. Just a second, let me wrap so my brain doesn't get too lost. So these are lithium-ion systems. There's 3 of them. They're effectively silent until the temperature gets up to about 65, 68 degrees, and then some fans kick in. Any energy storage system is going to have some kind of cooling or heating mechanism depending on the climate. In this particular case, it's never going to get too hot for them, but they do have some energy management. It's either going to be air-cooled or refrigeration circulation systems that provide that. In this particular case, we've got air, so there will be fan noises, but it's no more noticeable than any other fan system. We also have some small control systems down at this end. They have fans. They were running earlier. They're not right now, but when they kick on, you'll be able to hear them. That's as noisy as it gets here. So right now, I'm the noisiest thing here, but they will pick up some noise. So one thing you do want to consider is when you create your specification for your project site, you want to think about what's a reasonable decibel level for that facility and then establish that as a specification if that's a consideration. On an industrial site like this, not a problem. The airport is a noisy neighbor, so they don't particularly care. But in other cases, we do have a residence right across the street. They don't get any sound from this facility whatsoever. And again, it's just equivalent to a very large bathroom fan. So I welcome you to stand outside the gate later, see if one of those kicks on. If you drop by, you're coming to the airport, you can swing by and listen. And there was a question, I want to get to that and some other things.
I was just wondering, does customers make these themselves stateside?
You know, that's a great question. Industry is really working hard to onboard, and a lot of that was based on federal policy that came out in the last 2 years. So just trying to bring manufacturing back into the country. There, the fans are kicking on now.
I hear a high-pitched sound. What is that high-pitched sound?
That's the fans kicking on the control units.
Before the...
Oh. Sorry, I had chemo. I don't hear that high-pitched sound anymore, so I'm glad you can hear it.
I hear the fan now, but I also was hearing this very high pitch.
Yeah, you can hear it.
Yeah. Do you remember when you started to hear it? How far away were you?
Oh, it's right here.
Yeah.
As you approached. Okay, so call it 10 to 20 feet.
I'll have yeah, that's saying that they can hear that all night. I mean, that would be...
Yeah. The control systems, all control systems are going to have some kind of frequency noise associated with them. Just like when we turn our cars on, you're going to hear little noises as well. So these are going to have that as well. It's just a question of how far away are they detectable. Normally high frequency sounds drop off very quickly. It's the low frequency sounds that you can hear at a distance. So if you have concerns about noise that the facility is producing, you can consider abatement. For example, you can put up a sound wall. You can put up something with a mural on it. There are ways that you can, if you look at airports now, they have a lot more sound barriers down in the Bay Area to specifically abate noise. But normally the noise you really have to worry about are the low frequency sounds because those travel much farther and they're conducted through the ground as well. So that high-pitched sound, as we move away, we tend to drop off really quickly. But that's something important to pay attention to when you write up your specification for your sound is what are the frequencies and how far away and what abatement measures might be considered. Yes? I don't know. Everything inside of that box is owned by Tesla, and they won't let me open it because they want to ensure that it'll operate correctly. It's environmentally sensitive, so if it's raining out, they don't want it open. If it's really humid out, they don't want it open. I could probably look at the specification for the Megapack and tell based on the number of cells that they have, but I don't know. I would guess, or it might be less one, but I can tell you that that's as loud as this facility gets. Even with these running, when their fans kick on, Those are slightly noisy. They are not on right now. So this is roughly what this facility would sound like, worst case. These fans are a little, it might add a little bit more ambient. Generally, these are going to be noisier. So I don't know that you would notice these unless you were at the other end and you could block the sound coming through. Then you would hear these fans, but they would be no louder than those. It may add up a little bit. I have not noticed when they're running both together that the threshold is up noticeably. Yes?
I just wondered if you've ever had a problem with the Teslas when it got too cold. It sounds odd because you see the Teslas on the outside of people's homes in like Colorado and so on, and they're walking by it and there's all this snow. But I have a Tesla battery in my garage, and when it has gotten too cold, it just went nuts. It did not. It wasn't dangerous, but it wasn't like turning on and turning off at power. It wasn't allowing the battery to fill up at the correct times and to release energy at the correct times. It took a few days for that to calm
stabilize,
down. And so what I had to do, even though this is in my garage, is just put a little lamp in there with an old-fashioned bulb that created heat and turn that on when it gets like below freezing. But if it hits 28 in my garage, it loses its mind.
Yeah, early generation electric vehicle manufacturers kind of discovered that same challenge, that every piece of electronics has an operating temperature range and then a destructive temperature range. So that operating range is narrower, and that's where it'll optimally perform. So you want to stay within that. So they have now developed thermal management systems. So it's both to keep it from getting too hot as well as to keep it from getting too cold. For this particular site, I don't think there was any need for them to specify heating systems for this particular type of unit. In a home setting, it may be different, and the power packs, the Tesla power pack is a much smaller unit, so different requirement.
Yeah.
Are we all still here?
And mine was put in 2020, so I don't know.
Yeah, and what generation that equipment might be. Yes, please. 2019 was when we started to construct, and I think these mega packs, these are the first generation mega packs, and they went in 20, late 2019 or early 2020. Just lithium ion. There's now lithium ion phosphate, but this is before that. So these are the. Yeah, I do not know. They're probably cobalt. Yeah, but I would have to look that up. Wouldn't want to misspeak. But I would say they are Tesla's first generation. I think we're on our third generation of chemistry now for large storage systems. And so the things that they're seeking are to reduce cost and to improve safety. So I'm sure there's different viewpoints on what problems lithium-ion batteries have. I would point out that probably 90% of us have lithium-ion in our pockets right now. I have two. I'm surrounded by it. So it's a proven technology, but every technology has its challenge. Every energy source comes with issues. Who has a propane tank at their house? Propane has challenges. Who has gas in their car? Gas has challenges because it's an energy source. That's what makes it great. It's concentrated power. So you have to pay attention to that. You have to make sure there are standards. You have to make sure the safety is paid attention to. So for Tesla to get this to market, they have to take it through various standards organization and have it tested. Also, for us to construct at this site, we have a safety plan that had to be followed as far as how the system was designed, types of spacing. We also have an emergency response plan, and we have an annual plan we have to submit with the California Environmental Protection Agency regarding all of our hazardous materials, how they're managed, how how staff is trained. So I have samples if anybody wants to look through that. And I just recommend that anytime you're constructing a project of this type, you make sure that you pay attention to safety. There are risks. You just have to manage them. So in this case, this is our safety plan and hazard review to identify what issues may be on site and how we will address them. And then this is the emergency response plan. If things do go bad, then how do we deal with that? We also meet with the various first responders to make sure they're trained up. And they've been great to work with because they're very curious about this. Batteries are showing up all over the place, and they're less concerned with this and more concerned with those of us with batteries that are in our homes. Because here, this is a controlled facility. There will be government people involved who are paying attention, doing their homework, following the paperwork, updating it annually. And in our home, I have battery systems, and I'm thinking, when was the last time I looked at it? I should go out and brush the cobwebs off at the minimum. So it's certainly something to pay attention to, and RCA is working with Blue Lake so we can make these things available to them and also help writing specifications. Yes? That is the correct response for a lithium-ion system. It's metallic, and it just does not want to go out. It's similar to magnesium. That if you're in a car manufacturing facility and you're using magnesium, it's the same response for that material based on the element itself. So the response is to let it burn out. Yeah. You also want to make sure you space them appropriately so that as one is burning out, then you can cool and protect the other assets so they don't ignite as you allow whatever is on fire to extinguish. There's 3 batteries here. And if you look, there's a space in between them. 2.3 megawatt hour. For all 3 together. 3. The megawatt is the total instantaneous load that can be pushed out by the battery. Megawatt hours is measuring its total capacity. So it stores 2.3 megawatt hours worth of electricity. I'm sorry.
This would be about divided by 4 megawatts.
2.3 must be 2.3 megawatts.
So we would
It could flow 2.3 megawatts for 1 hour. In this case, I was not concerned about that because there were only 2 manufacturers. This is one of the unique aspects of this system is it's a DC to DC coupled system, which means it's taking DC rather than AC power. Let me back up a bit. See this box right here? That's an inverter. So it takes the DC power produced by these solar panels, converts it to AC power, then feeds it to the airport where it can be used instantaneously. The rest of the array stays DC power, and it feeds into these devices, which feed directly into the batteries. So these are DC batteries, and it's DC production by the solar arrays. The benefit there is there's no conversion loss when you go from DC to AC, back to DC again. So that's why we did that. At the time, there were only 2 domestically available products. The one we installed first failed. Tesla realized that was a bad choice. They selected Dynapower. So I'm very happy at whatever noise level they make, up to a point. But I did not ask them because they were the only option for us at that time.
And there's 3 apps that you could come and stand next to it and read the decibel.
And it was in the specification sheet. So it wasn't anything that triggered a flag. Yes, absolutely. Absolutely.
I have a question. So, if these 3 yards and for the infinite emission your initial one included.
That sounds like
So then you
reasonable
would be
math.
multiplying this sample. I mean, it wouldn't just be this size. We're talking about 8 times 3, 6.4, 16, megawatt. We did 100 megawatt facility. You have to think about how,
Yeah.
and what would be the noise combination.
Yeah, and so for that, you probably want to ask a sound engineer to calculate what that sound would be.
Keep in mind that the size of these are bigger because of the technology that are in these. These are lithium ion, or yeah, they're lithium ion, not the lithium iron phosphate.
Okay, but let's clear this up, that lithium iron phosphate are they're lithium ion batteries. They're just a type
Right,
of
but
lithium ion
but
batteries, and actually lithium iron phosphate has a lower energy density, so they would probably need to be made
From a
in all
dis-
truthfulness, about 30% less energy density than these.
So from a design perspective, you just pretty much want to lay out your criteria and say, okay, I want 20 megawatts, and then your various respondents will then say, well, this is the size of footprint, this is how much, if you have sound as a requirement, then you put down, this is what kind of sound, make the manufacturers do the sound engineering for you, and say this is the level of decibels that would be hit by a system of that size, this is how much footprint I need, this is the amount of setback for your fencing, from a safety perspective. You know, put the work on the respondents to tell you, for their technology and their design implementation, what size you're going to need. Yes?
I think that for myself included, when you say megawatts versus megawatt hours,
Yeah.
can you give us dumb it way down for us and tell us how to
Sure. A hair dryer. You're running a hair dryer. It's a 1,000-watt hair dryer. We all see those numbers written on it, but what does that mean? It means that if you run that 1,000-watt hair dryer for 1 hour, you will use 1,000 watt hours. So it's just 1,000 watts used for 1 hour. So a 2.3 megawatt battery system means it can deliver 2.3 megawatts of power for 1 hour. So you don't have to run that hairdryer full on 1,000 watts. You can turn it down to 500 watts, and then it'll take you 2 hours to use up 1,000 watts.
Okay, so if this battery, if these batteries, 2.2 megawatts, are fully charged,
Yeah.
and they run full out for 1 hour, will they discharge?
Yes. Yes.
Okay, so 2.3 is their maximum charge, and they can discharge that in 1 hour.
Yes. We'll never do that because we never want to draw the battery all the way down for 2 reasons. One, it's not healthy for them. They have design limits, so you have to talk about state of charge and how low are you willing to go and how high are you willing to go. So we won't drop it below 20% because of the technology of these batteries, and we don't like to go above 96%. But in fact, we actually reserve about 40%. And if we have a storm mode where we think a storm's coming on, then we'll reserve the whole battery capacity. So
So when people say megawatts and then they say megawatt hours, how is that different? I mean, the way you describe it, it sounds like megawatts and megawatt hours is like the same thing.
you know what? And I did this week. It's a little more complicated than that, and we're not going to get through all of the math in this particular meeting. Because we've oversized these batteries, they will take in 2.3 megawatts or discharge 2.3 megawatts. That's their capacity. They think about it from a hose perspective, charging hose. But we've oversized them so they can do that for them.
So if 2.3 is kind of the difference between 20 and 96, not where the 2.3 lies. So you would probably take the bigger percent that allows you to
We can take in 2.3 megawatts worth of power out of this array. All that power can just flow right into the batteries until it gets up to a certain charge level. And then that's when we're topped off.
Okay, so what is your experience with running this plant? How many times a day do you charge people?
It could be anywhere from 1 charge to 40. It really depends on what the energy market is doing and what the price signals are.
I remember a long period of a year or something, you have sometimes numbers between that more than 40.
We need to have the system operating. Now that we've replaced out all the hardware, we can start collecting that data. We don't have it yet, but I would say on average, about a dozen a day discharge charge cycles. That's because we're just responding to market demand.
So the 2.3, you'd actually be putting that 2.3
Yeah. And then you just add up how many minutes each one of those pulses equal, and that's the number of megawatt hours.
Do you have someone on site here 24 hours a day that responds to any emergency? Or how close is your response?
Our emergency responders is the Arcata Fire Department. So they're in McKinleyville. They have their closest, I forget what they call it, the joint agreement.
Right.
So they're 3 minutes away, I think. And the system itself has built-in alarms. So that alarm goes immediately to a computer in my office, and it also goes to my cell phone. It'll go to several other people. The airport operations crew is really helpful. They're on site 24/7, I believe. There's somebody paying attention. So if we miss it for whatever matter, they'll see it. People driving by too. So just like any facility, it's an unstaffed facility to answer your first question. But the site itself does include multiple alarms.
It's electronically monitored 24/7.
Yeah.
The system is monitored 24/7. We have someone on it all the time. One thing I wanted to mention that I was sorry. One other thing I wanted to mention to one of your constituents is this facility is required to be certified by the state, EPA, SURS, CAPA. So there's a whole hazmat key component that we are registered for, have all the documentation in the shed. We also, I just scheduled a safety training and site walk with Arcata Fire Department, our authority having jurisdiction, to go over the emergency response and have them become familiar with this facility, just like you being able to come and see it physically and talk about their, what their concerns are and their questions. We did that annually. We did that last year. I'm doing it again this year. I do it 3 times so I can catch all 3 battalions. This year I'm also including the Humboldt Del Norte Hazardous Materials Response Team because they haven't had an experience with a battery energy storage system before, or a BESS. And also I'm bringing in the Humboldt County Office of Emergency Services, and they are going to learn about this. Humboldt Bay Fire has an interest. I've reached out to Chief Vinuku and told him that all of the Blue Lake Volunteer Fire Department members can come and attend this. So we do a training. All of them are... We wanted to be sure that all of the emergency responders had an experience with getting close to and understanding how this works. What is it, the chemicals that come off? What is the procedure? They're going to stand outside the fence and maybe pour water on it. No one's coming in this facility to do anything, because if the batteries start, then we just have to let them go. And they have to do some particular monitoring. So that involves a whole emergency response. So that is all part of what you would need to consider into making sure whoever goes and develops your facility, that you have all of those components which they're required to do. And now the California Public Utilities Commission is also requiring some safety maintenance requirements of if you are going to, say, put the front of the meter, put the energy onto the grid, you're also required to follow their requirements too. So there's a lot to kind of take a look at as far as going on. The other piece I want to mention, this facility is going to be here longer than most likely I'm going to be alive, because I don't think I'm going to be around.
No, don't say that.
So this is, I just want you to see, you know, 20 years from now, this place is still operating. And also, please consider operations and maintenance of the facility, because yes, we don't have someone here 24/7. We have a technician that monitors everything. Dana and I right now come out and basically get under the panels and start weed whacking and checking and
We're glorified
cleaning
landscapers.
and yes, we hire. It costs about maybe $10,000 a year vegetation management for this type of site, and that's just the mowing part. And then they also have to, because we have to follow the FAA and the work with the airport, we have to maintain the perimeter. My favorite word I'm going to throw at you is agrivoltaics, and someday I would love to do the combination development of solar and agriculture and combine it. Humboldt County is great for doing sheep grazing under these panels. If you're going to do that, please build the panels up 3 feet off the ground. Leave them 2 feet or 1 feet. It's also very difficult for my mower to come in and mow. There's a lot of operational considerations as well as the safety components and actually making sure what you have is a good product.
Mary Ann, that triggered a reminder for me. One of the real benefits of the batteries, they provide energy when other sources of energy are not available, like when the grid goes down. But when you site your batteries, you want to think about where to put them and what hazards might they be subject to. So make sure you do a hazards analysis. Is it flood, fire, high wind, whatever? Make sure you take that into account.
In Blue Lake, one of the concerns I know is that what if the river, it'd be set up above the high water mark, essentially the pads would be set so the water would never get to it.
Yeah, it's a business trade-off, because the more you build something up, the higher your costs go.
Yeah, of course.
And so then you're having to weigh what periodicity are you paying attention to. The 50-year flood, 100-year flood, and with climate change, the numbers are getting screwy. So that's definitely something that needs to be considered in a thoughtful conversation about what is the right height to install them to address the flood risk of the river.
That's a site consideration.
To sell the concept to Blue Lake, where there's a lot of pushback, you have to consider the 100-year.
Yeah,
In other words, the worst case scenario.
yeah. Which is
And
500 years. But we don't have recorded history to tell us that. I have 2 more questions right here. And then
RPA right there, and we're doing, I understand I have a here, and these batteries will last forever, they have to be replaced. So when do you eventually have to replace the solar panels as well? So I'm wondering, when do you have to replace the components of the system, and how much will it cost? Will it double your cost, or?
our contract with Tesla is for a 25-year life. Our weakest link are going to be these inverters here, which are going to have a 15-year life. So those are going to be the first components for us to swap out. I think the batteries are 20-year. I know they have a 10-year warranty. And in 10 years, we're going to have something better to replace them with, but I have not calculated the full life cycle costings to include replacing the batteries. And the solar panels have a 25-year life, so I think that's what caps the overall cost. So really, that's what we're aiming for, is to keep these as productive as long as possible and replace the other components as we can. The project will pay for itself within its project's lifespan, but not a day after. And because we did have a technology failure, we're actually going to lose a little bit of money, but Tesla's going to be accountable for, they've already paid for repairs as part of their performance on meeting the contractual needs.
And I want to
Had
say,
another question here.
yeah, hold on just a minute. I just wanted to say one more thing. We do have we included in our contract a decommissioning plan.
Yeah.
So we have done a decommissioning plan, looking to the future to see at the end. So I would say highly recommend looking at a decommissioning plan, and we're actually saving money towards that end. So as far as owning a facility, we look towards the end to see, we're going to have a cost, and we have a plan in place to do that.
So cybersecurity, does this have cameras watching it all the time?
Yes, it
Because
does.
you could cut that fence and you could cut those locks and you could get into the system pretty quick.
Yeah, we
Yep.
have that.
So you have cameras
Yes.
watching it and
It's under surveillance, at least the switch yard. We don't have this end of the field at all, but the switch yard is the key part of it. If any of the doors are opened, it immediately alarms, so we know when there's an
Yeah.
intrusion.
police would come. And
The normal well, cybersecurity
Sure.
really is an inside job is the main problem. So at least for our control system, there's 3 layers of protection, and we have a cybersecurity plan. PG&E as a utility is a sweet target for terrorism, and we are directly connected to the grid. So that was a big part of this project, was to document the potential attack surfaces and potential vectors over those surfaces to make sure that we aren't a weak link into the greater grid. So yes, we have a lot of
Crew band. What'd you do, Ken?
we can stay here or move. Oh, now it's saying you can advance. Thank you.
I was waiting towards the end to ask, I wasn't sure if you're going to be addressing financing and also I want to my understanding of solar is that the solar panels don't die in 25 years.
They degrade. They'll probably be somewhere between 78 and 80%.
But they would still be functional.
Completely functional.
As long as you maintain them well, you're going to need someone to get up there and scrape the LP off and watch hire someone to do that work, like we hire someone to do vegetation management. You actually have to have a tech to do the software maintenance, checking all the inverters, making sure the hardware's working, all the wires are checked, and that all of the equipment. That is operational.
Hang on.
It depends, because the technology has moved forward, so there may be the capacity we don't have the capacity.
But it's a good point. It's good to put out several different system sizes so that you're going to have a fixed cost. Because any fixed cost, a lot of times you know that big spread those fixed costs out. So you want to look for several different sizes so you can compare and contrast to see what works best for everything.
So just for my recording, I was wanting to have a conversation, just someone to talk back and forth to me, so I can show the actual level. So if someone else could talk, like if you would just say something, just a conversation.
That this is the fan sound, which is basically keeping safe the lithium-ion battery systems inside each unit. There's a unit in each door, and the fan system operates and monitors the battery 24/7.
Perfect. I just wanted to show that the fan was about the level of your voice. I'm hearing you about, so we can still have a conversation while the fan's going.
Yes.
That's mostly what I needed. Thank you.